Hey everyone, so today we're going to be trying out a challenge called back nines. It's a pretty fun algorithm to work on, and it involves basically creating a function that allows us to sort an array and then return it back. So stick around for the challenge if you'd like. Good luck, and let's get into it. Okay, so like before, if you want to pause the video now, take a look at it and attempt it, please do so. And I'll kind of go into my approach for how I would look at this, and then go into the actual code of how I would actually code this out. So we're creating a function back nines, which is saying basically it's going to take in an array of numbers. The function is going to take all the nines that are in the array and move them to the back of the array. It must be done in place by mutating the original array. So that means you can't create like a net new array and then return that. It needs to be the original array being passed in. And then basically after we're done modifying it, we're going to return that array back. So in this situation, you can see that we have, this array that has, again, all numbers, 10, 4, 9, 2, 3, 4, 9. And what's happening is all the nines that are in there are basically being put to the back of the array. So since we're modifying this array in place, as we're running through it, we have to think about what we want to do when we encounter a 9, or if we don't encounter a 9, what do we do? So the first thing is when we hit this 10, we know, okay, 10 is fine, don't need to touch it. 4 is fine, leave it alone. Now we have 9. So we might be thinking, okay, what's the best way to kind of get this over to the end? One thing we could do, but this would be kind of inefficient, would be if we push if we move the 9 to the 2 spot and then kind of swap the 2 to the 9 spot, right? And then iterate through again a second time. And now since the 2 and the 9 swap places here, the next time we iterate through it, so if we go through it again, 10, 4, 2, oh, this is a 9, then we say, okay, let's move 9 forward again. And then basically kind of swap places with the 3 here. And then it keeps on basically moving up and up and up until we are hitting 9 at the end. And then if there's a 9 in front of it and there's really no other numbers in front of it, then we know at that point that we have all 9s at the end. But the problem is it's very inefficient because we have to run through it multiple times until we basically have all the 9s at the end. So there is another more efficient way that we can look at this. So let's go back. So this method would utilize a pointer. And what that means is that we kind of keep track of where we are in the front and where we are in the back. So if we use I, for example, I will keep track of where we are in the front. And then if we use J at the back, that'll keep track of where we are in the back. And let me just color these again. So in this situation, let's kind of keep track of what's happening here. So with 10, again, 10 is nothing, right? That we don't care about 10s. We only care about 9s here. So we say, okay, 10, sorry, I don't care about you. Let's go over to 4. So 4, sorry, I also don't care about you. So I'm going to move over to 9. Now what's happening here is we could swap I and J, but the problem is right now J is looking at 9. If we swap 9 with 9, then we really have accomplished nothing. So before we even start iterating through this array, we need to find the first number that's not 9 at the back of the array. So what should be happening first is if I reset this, J should actually be saying, hey, okay, you're a 9. I don't want to move you. You're at the back already. Let's go over here. Oh, hey, you're a 4. You need to be swapped out. So now that we know J is pointing to a non-9 number, that's kind of hard to say, we can have I start to iterate and move through and look for that 9. So again, 10, no, 4, no, 9, yes. So now at this point, since I is equal to 9, we could have it so that way we switch places so that way I is equal to J, and then basically J is equal to the value that was I beforehand. So now what happens is that since this 4 is being swapped over, the 4 will now be here, and then the I, which was at 9 before, will now be here at the end. So now that you know that approach, try to think of a way using what we just said to approach this situation and give it a shot. I'll be jumping into the code now, so if you don't want to see that just yet, then just pause the video, but let's get over to the code. All right, so we're going to basically create a function just called const back nines, and it will basically accept an array, and that will be that for now. So we'll kind of open that up, And then similar to before, we're just going to console log passing back nines. We'll just do 10, 2, 9, 3, 2, 1, 9, for example, right? And we'll do, I guess, like one more example. So this one's a lot more complicated here. So I'm going to comment this one out because I don't want it to get confusing, because it's going to be console logging both of these, and I only want to do one at a time so we can kind of keep track of what's going on here. Okay, so what we're going to do first is declare our pointer. So we agreed on we'll just call it I, and we'll just set that equal to 0 because we want to start at the beginning of the array. Then we're also going to set j, and we're going to set that equal to array.length, but we have to subtract 1 because the length of this array, for example, is 1, 2, 3, 4, 5, 6, 7. And so if we try to access a value at the index of 7 for the array, it's going to be undefined, right? Because if we do, it's 0, 1, 2, 3, 4, 5, 6. So there is no 7th indice here. So we have to do -1. So 7 minus 1 is 6, and 6 is the last indice at this point. Okay, so we have our pointers, right? And so what we're going to do is we're going to create a while loop, and we're going to say while I, which is 0, is less than j, we want to do something. And that something will be, first, like we talked about, we're looking to see the number at the end of the array. Is that a 9? And if it is a 9, we need to move j down a little bit because it shouldn't be focused on that number. If I pull up the example again. So if I pull up the example again, remember when this j was at 9, we needed to move it over to 4, right? Because 4 needs to be the one that gets swapped out, not 9. If we swap 9s, then we do nothing. It needs to be pointing at a number that's not 9. So we're going to say if array at j is equal to a 9, then basically j minus minus, right? Because we need to move off of that last number. So in this case, when it sees that, it's going to go, okay, j is 6 beginning, and then we're going to say, okay, is array at 6 equal to 9? It is equal to 9, so subtract j. So of course 6 minus 1 is 5, so now it's pointing at this 1. That's what we want. So now we can continue the function. Now what we need to do here is establish an if-else, because if array at j is equal to 9, then we know that we're going to move down j, right? But otherwise, if it's not equal to 9, so now that we know, for example, we have 1 here, then we need to do something else. So what we can do here is say else if array at I is equal to 9. So what we're looking to do is that if array of I is equal to 9, that means basically we're going through the number. Is it 10? No, run again. Is it 2? No. Now we have a 9, right? If it's equal to 9, now we have to swap places with j, because remember, j was pointing to 1 at this point. So now we need to swap places. And to do this, we're going to create a temporary variable. Let's say, for example, let swapped number, let's call it swap num, equal array at j. And the reason we're doing this is because we want to keep track of the value that's here, right? This 1, we don't want to lose it, because what's going to happen is when we set, we're going to swap them, right? So when we say array at j is equal to array at I, what this means is that, so for this array of j, which is 1, we're setting it equal to 9, right? Because array of I is 9 at this point. But what happens is that by doing that, we lose the value of array at j because we're setting it equal to array of I at this point. So if I try to say, okay, that means that array of I is now equal to array of j, that's going to be a problem because array of j is now 9. So if we set array of I, which is 9, equal to array of j, which is 9, that's not going to do anything. So we've lost the value of array of j by assigning it to array of I. So to preserve that value, what we can do is just create a swap number variable. And now what we can do is say, okay, array at I, you're going to be equal to swap num. So now we retain the value and we're able to swap places with it, right? So now we have cases for, okay, what happens if we have, j pointing at a 9, we decrease it, which is great. If array at I is equal to a 9, we swap places. That's great. But the problem is we're not actually incrementing, right? So if in the first case where we have 10, we're going to say, okay, is array of I equal to 9? It's not. So what happens? Nothing happens. So we need to create an extra else statement that will just say I plus plus. So now what's happening is that in this case with 10, since it doesn't satisfy either of these if statements, we'll just increment I. We'll do it again. So 2 isn't truthy for any of these previous if statements. So I plus plus again. Now we hit 9. 9 works for this if statement here because array at I is equal to 9. So you swap them. And so basically, after we're done with that, all we have to do is just return array. And so if we take a look at this, it doesn't work. I have to put it outside the while statement, not. Okay, there we go. Okay, so you can see in this situation, 10, 2 hits the 9, right? So the 9 switches with the 1, and then you have the 9s at the end. Now let's really put it through its paces and check it out with this longer console log down here. And you can see that even though we have all these different 9s here, and there are 1, 2, 3 9s, ultimately it gets all those 9s to the back of the array and it's returned properly. So this situation works. So take some time to play around with it, and if you have any questions, please feel free to drop them down in the comments below, and I'll try my best to go ahead and answer them. But thank you for sticking along with this challenge. I hope you had a good time. Keep on watching. Please subscribe, comment, like, whatever you can do, as that really helps to help my channel grow, and I do really appreciate that. I'll see you in the next video. Thank you.